Welcome to this advanced training module on the foundational concepts of generative AI. Today, we will not only explore what generative AI is, but we will take a deep dive into the critical challenges of fabrications, reliability, and bias, and how to govern them effectively. Let us get started. Let us begin by establishing a foundational understanding of generative AI. What exactly is it? While traditional artificial intelligence focuses on analyzing data to make specific predictions or classifications, generative AI represents a paradigm shift because it actually creates new, original content like text, images, or code. At a basic level, it relies on massive, pre-trained models that understand natural language prompts. Why does this matter for your business? Because this technology unlocks unprecedented automation and conversational capabilities that were unimaginable just a few years ago. How it achieves this is through large language models, or LLMs, which map the complex linguistic relationships between words to reason over inputs. However, as we dive deeper into Gen AI ops, the focus for business leaders must shift. You are no longer just building algorithms, you are managing the unpredictable nature of content generation. This unpredictability introduces severe enterprise risks that we must actively manage to safely deploy these technologies in real-world scenarios. Take a look at the flowchart on your screen, which contrasts traditional AI with generative AI. On the left, you can see traditional AI branching directly into prediction and classification. This was the era of structured, deterministic outputs. On the right, generative AI flows into content generation, representing our current technological leap. Follow the flow downwards, and you will see that this generation capability is powered by LLMs and pre-trained models. But the most critical part of this diagram is the final node, new enterprise risks. Because these models generate content dynamically rather than selecting from a pre-approved list of answers, they introduce entirely new vectors of risk into your business workflows. This visual serves as our roadmap for today. We must understand that adopting the technology in the middle right inherently means we must build safeguards for the node at the bottom. In the following slides, we will break down exactly what these new enterprise risks are and how you can architect your systems to overcome them effectively. Now we tackle one of the most prominent challenges in generative AI, fabrications, frequently referred to as hallucinations. What is a fabrication? It is when a generative model produces an answer that sounds highly authoritative and grammatically perfect, yet is entirely factually incorrect or invented. Why does this happen? The foundational mechanics of these models rely on predicting statistical patterns in language rather than verifying facts against an objective truth database. They are optimized for fluency, not accuracy. How does this impact your organization? If you operate in regulated sectors like healthcare, finance, or legal services, acting on fabricated information can lead to costly operational mistakes and devastating reputational damage. As we dive deeper, you must understand that you cannot treat an LLM as a search engine. Without proper boundaries, a model might even make ungrounded inferences about individuals, misattributing actions simply because the statistical pattern dictated that response. We must actively architect solutions to prevent these fabrications from reaching the end user. Let us examine the mechanics of a fabrication through this diagram. We start on the left with the user prompt, which feeds into the LLM processing node. From there, we hit the crucial decision diamond, the prediction mechanism. Because the model relies on predicting the next best word based on training data, the path splits. On the top path, if the statistical pattern happens to align with reality, you get an accurate output. However, look at the bottom path. If the pattern lacks verification but still flows naturally, it generates a fabricated output. This directly feeds into the final, critical node, business risk and trust erosion. This diagram visually demonstrates that fabrications are not a bug, they're a fundamental feature of probabilistic language generation. It clearly highlights why deploying a raw, unfiltered language model directly to your customers or critical business processes is incredibly dangerous. To mitigate the bottom path, we must introduce external verification steps, which leads us directly into our real-world use case on the next slide. To truly grasp how to handle fabrications, let us explore a highly relevant, real-world use case. Imagine a global retail company that decided to use generative AI to automatically create thousands of product descriptions. However, during testing, the leadership team discovered a major issue. The AI was occasionally fabricating or inventing product features that did not exist. Why is this critical? Because selling a product with fabricated features leads to massive customer returns, legal liabilities, and a shattered brand reputation. How did they solve it? Instead of abandoning the initiative, they integrated a fact-checking layer that cross-referenced the AI's outputs directly against their verified enterprise product database. This technique is known as Retrieval Augmented Generation, or RAG, which grounds the AI in trusted data. Deep diving into the business value, this retailer did not just fix the problem, they transformed a massive challenge into a lucrative opportunity. Because their descriptions were now highly accurate, they launched a new service offering verified AI-generated descriptions to their partner brands, creating an entirely new revenue stream. This flowchart maps out the exact strategic pivot our global retailer took. At the top, we begin with Gen AI product descriptions. When fabrications are detected in the decision diamond, the immediate action taken is on the right. Implement RAG fact-checking, This step forces the AI to check its work, moving down to the cross-reference with Enterprise Database node. By anchoring the AI strictly to known, proprietary data, the system successfully outputs to the Verified Outputs node. The final node illustrates the ultimate business triumph, new revenue stream via partner brands. This diagram is vital because it proves that AI challenges are not necessarily roadblocks, they are engineering problems waiting to be solved. By intercepting the fabrication before publication and grounding the model in truth, the company built a highly defensible, trustworthy AI architecture. This is exactly how you must approach generative AI implementation in your own enterprise workflows. Moving beyond fabrications, we must address the critical challenge of reliability. What does reliability mean in this context? It refers to the consistency of your AI's outputs. In traditional software, if you input a specific query, you get the exact same answer every single time. Generative AI is fundamentally different. Because of its probabilistic nature, you can ask a model the exact same question twice and receive two entirely different answers. Why is this a problem? If you are trying to automate enterprise workflows, inconsistency is your enemy. Unpredictable outputs can severely disrupt decision-making pipelines and user experiences. How does this manifest in the real world? For regulated industries, variability poses massive compliance and operational risks, as you cannot guarantee the system will adhere to required standards every time it generates text. Deep diving into this, business leaders must shift their mental models. You are no longer managing deterministic code, you are managing a highly capable but variable reasoning engine. Establishing predictable performance from an unpredictable model requires specific engineering guardrails, which we will cover next. Look at the diagram on your screen to visualize the reliability challenge. On the far left, we have an identical prompt being fed into the generative AI model. In a traditional deterministic system, this would lead to a single, unified output. However, here we see the flow diverging into output variation 1 and output variation 2. While variation can be fantastic for creative writing, it is highly detrimental to enterprise automation. Following the paths further, output variation 1 leads to workflow disruption, while output variation 2 triggers a compliance risk. This split perfectly encapsulates why out-of-the-box generative models are difficult to scale in strict business environments. As a leader, when you look at this flowchart, you should realize that you cannot allow raw, variable outputs to interface directly with your core operational systems. You must build structural constraints around the model to force these diverging paths back into a single, reliable, and compliant outcome. How do we actually fix the reliability issue we just discussed? We must implement robust mitigation strategies to enforce consistency. What this entails is surrounding the AI with strict parameters. The basics involve advanced prompt engineering, adjusting model settings like temperature, and utilizing safety system messages or metaprompts. Why do we do this? To ensure the AI strictly adheres to your domain-specific standards, formatting rules, and corporate tone every single time it runs. How is it executed? You must develop internal engineering expertise to build clear guardrails. For example, if you need highly predictable, factual answers, you instruct your developers to set the model's temperature to 0, which drastically reduces its randomness and forces it to prioritize the most likely, deterministic output. Deep diving further, techniques like few-shot prompting, where you provide the model with a few perfect examples of the desired output within the prompt itself, train the model in real time to match your exact formatting requirements, thereby bridging the gap between probabilistic generation and reliable enterprise automation. This flowchart illustrates the technical pipeline required to transform variable AI outputs into reliable enterprise assets. We begin at the top with the variable AI output, representing the raw, untamed nature of the model. The first mitigation step is to apply metaprompts, which injects overriding system rules that govern the AI's behavior. Next, the flow moves to set temperature to 0, mathematically stripping away the model's creative randomness to favor predictable outcomes. We then pass through use few-shot prompting, which provides the model with exact templates to mimic. Finally, the data flows through domain-specific guardrails to catch any remaining anomalies. The culmination of this stringent pipeline is the final node, consistent and reliable enterprise output. By implementing this step-by-step constraint system, you effectively tame the generative engine, ensuring it performs with the reliability required for mission-critical business processes. Our third foundational challenge is arguably the most complex: bias. What is AI bias? It occurs when the generative model reflects and amplifies the prejudices, stereotypes, or demographic imbalances present in its training data, leading to unfair or skewed outputs. The basics of this issue are evident when AI is used for high-stakes decisions like hiring recommendations, lending approvals, or generating representational content. Why does this happen? Because large language models are trained on massive scrapes of the internet. They ingest decades of human-generated text, which inherently contains historical societal biases. How does this affect you? Failing to address bias introduces massive ethical and legal risks. It can irreparably damage your brand reputation, erode customer trust, and, for global organizations, result in severe regulatory penalties. Deep diving into the impact, we must recognize that bias is a systemic issue. If left unchecked, AI can disproportionately harm minority groups or deny consequential services to vulnerable populations. Tackling bias is not just about fairness, it is a critical business imperative. Let us trace the life cycle of AI bias using the diagram on your screen. It starts at the top with internet training data. As the arrow indicates, this data naturally contains historical prejudices, which feeds directly into the LLM training phase. Because the model learns to mimic its input, this inevitably creates a biased AI model. When businesses deploy this raw model, the flow continues down into skewed outputs in lending or hiring. The cascading effect of these skewed outputs is shown in the subsequent nodes, generating immense ethical and legal risks, which finally crash into regulatory penalties and loss of trust. This flowchart is a stark warning. It illustrates that bias is not injected maliciously by developers, it is inherited organically from the data ecosystem. Therefore, if you blindly trust the model's outputs without intervention, you are systematically importing societal flaws directly into your corporate decision-making architecture. To combat the pervasive threat of bias, we must implement rigorous, proactive mitigation strategies. What does this mean? It means actively designing your AI systems to be inclusive and fair by design. The basics involve assembling highly diverse design and testing teams, utilizing advanced bias detection tools, and establishing a cadence of continuous auditing. Why should you invest heavily here? Because mitigating bias transforms a massive risk into a distinct competitive advantage. Companies that champion responsible AI earn deep customer trust and stand out in the marketplace. How do we execute this? You must mandate human-in-the-loop reviews, ensuring that AI is treated as a co-pilot, not a final decision-maker, particularly when impacting human lives. Deep diving into advanced tactics, we employ AI red teaming. Unlike traditional security red teaming, AI red teams deliberately probe the model using adversarial prompts to uncover hidden stereotyping or exclusionary language before the product ever reaches the public. By aggressively testing for fairness, we ensure the system treats all demographic groups equitably. This flowchart maps out the defense mechanisms used to neutralize bias. On the left, we face the biased AI model we identified in the previous slide. The first line of defense is AI red teaming, where experts intentionally try to force the model to generate biased content to expose its weaknesses. The flow then moves to diverse team auditing, ensuring that the people reviewing the data reflect the diverse world we live in, catching nuances a homogeneous team might miss. Next, we implement human-in-the-loop review, guaranteeing that a human expert always validates consequential decisions. Through this rigorous gauntlet, we finally arrive at a mitigated, inclusive output. The terminal node shows the ultimate business reward, competitive advantage, and trust. By visualizing this process, you can see that fairness does not happen by accident. It requires a deliberate, multi-layered filtration system embedded directly into your AI deployment lifecycle. To conclude our training, we must bring all these concepts together under the umbrella of comprehensive AI governance and security. What is AI governance? It is a holistic, unified model that aligns your data practices, AI deployment, and regulatory compliance into one cohesive strategy. The basics require establishing clear usage policies, strict role-based access controls, and automated dashboards to track compliance. Why is this imperative? Because alongside fabrications, reliability, and bias, you face severe security threats like data leakage, shadow AI, and malicious prompt injection attacks where bad actors trick the AI into bypassing its own safety protocols. How do you build this defense? You must establish a cross-functional AI council to oversee strategy and deploy technological safeguards like prompt shields to block adversarial inputs dynamically. Deep diving into the architecture, effective governance means utilizing a defense-in-depth approach. You must secure both the platform layer with robust data encryption and the application layer with rigorous content filters and human oversight. Only then can you innovate with absolute confidence. Our final diagram illustrates the architecture of a resilient enterprise AI strategy through the lens of unified AI governance. Notice how the main node branches into three indispensable pillars: data governance, AI operational governance, and regulatory compliance, If any of these pillars fail, the entire structure collapses. Data governance flows down to prevent data leakage, ensuring your proprietary information remains secure. AI operational governance targets active threats, flowing into block prompt injections to stop bad actors from hijacking your models. Lastly, regulatory compliance ensures you can ensure auditability to satisfy legal frameworks. All three of these protective streams converge into the ultimate goal at the bottom: secure, scalable enterprise AI. This flowchart is your blueprint for success. By governing the data, securing the operations, and aligning with regulations, you empower your organization to harness the immense power of generative AI while entirely neutralizing its foundational risks. Thank you for your participation.